Just go live. Okay, awesome. All right, so this I think is going to be quite a fun one. We don't have too long though because it's actually Friday afternoon here in Australia, so I don't want to, can't spend too long. I'm just trying to figure out a way to get this thing. How do you do that? You get, oh, that thing pop out. Yeah, that's it. Okay. Really need to write a bit of, I think good to have that there. We're going to close that because I've got that information now as we go. Fantastic. Right, let's go to Twitch. Just make sure that's okay. Okay, that looks good as well. Just making sure. So let's make that nice and small. Okay, let's open this thing up, close that here. Okay, hi. So this is, as I said, I think this might be pretty interesting. So we've been writing a whole bunch of code and packages that, you know, that are really meant for, of course, use by applications, because all we've been doing are writing libraries. This is probably the first time where we're really going to be actually writing a program, a server that's actually going to do something that maybe might be interesting for actual users who aren't necessarily writing code. This might be useful for people who are, you know, actually, I don't know who would use this sort of thing. But the point is that it's going to be a good way to test all the stuff that we've been working on. This is actually a quick diagram that I just made of how this stream right now is actually working. We've got OBS that's actually getting input from a whole bunch of different places. Like we've got the camera, we've got the sound, we've got the microphone, we've got whatever. And then that is ultimately being streamed. It's actually connecting to the loopback interface on this same computer to a little FFmpeg script that I wrote that, as I said, listens on a loopback interface and will read the RTMP stream and then sort of have a T writer that just writes it out to both Twitch and YouTube at the same time. It doesn't do any encoding or re-encoding. All it's doing is just kind of, just maintaining the connection between the two things and just speaking RTMP to both of them, because there's a bunch of stuff that makes RTMP work. This is a network protocol, so it's all over IP. It does things like manages buffers and, lag and reconnection and all this dropped packets, all that sort of stuff. Runs over TCP. And then what happens here is that once let's take first example, Twitch will read in the thing from our RTMP connection, and then it'll actually, ultimately what happens is that it turns it into a bunch of MPEG transport stream packets. And then we'll write those to something that resembles a file. And then that's actually served over HTTP. And the way it serves those files is it has a bunch of 2 to 10 second long files, and it'll serve those over HLS. So if anybody's watching on Twitch now, maybe not, I don't know. But that one is going to be your, most cases a web browser will be reading media stored in MPEG transport stream files over HLS. Now, if it's going to YouTube, it uses a slightly different container format and sort of like playing protocol, let's say. But the point is that it's the same idea, just looks a bit different. That's really cool. I think, YouTube and Twitch are amazing systems, but they're really big systems. What we're doing on, in these streams is we're kind of deconstructing these things to understand how they work. which is interesting because it kind of demystifies the whole thing. Part of that is, of course, writing an HLS package, which we've done. We can now read and write playlists okay. I think it sort of works. Obviously, it's not a very complete implementation. We don't do the whole protocol, or we don't implement the whole spec. But I think we've got enough to actually build something useful. The idea is that in OBS, which I have here, although it won't show up because I've got it hidden. But anyway, point is that in OBS, you can stream, but you can also record. Streaming is over RTMP, over the network. But what we can do is we can actually have a custom output in OBS that uses FFmpeg to do kind of whatever else that FFmpeg can do. So the fun idea that I came up with is that we can actually just write the video that OBS is, putting together into MPEG transport stream, into MPEG TS, and we can actually write that over a Unix socket. And our little server will read the data over the Unix socket. That's super reliable, right? And we'll chunk it all up. We'll write it all to disk in sort of a cache directory somewhere. And then we'll make a playlist out of those files, an HLS playlist, and then we'll have any viewers who are watching at the same time could actually try and, stream our thing directly from our own little server that we've got somewhere. Because Go has got such a great standard library, in particular the net package and of course the HTTP package for a really high level thing, this should be pretty easy because all we're really doing is we're just making use of Go's, the built-in HTTP file server. That's, works very well. And of course, reading over a Unix socket, well, that's pretty easy too. We just, we're going to dial the connection and then we're just going to be reading data in. There'll be a few tricky things about splitting up the video the way we want to. So it'll require a bit of knowledge about MPEG transport stream. There's sort of ways to do that reliably. But I've actually done a bit of work with MPEG TS already. So hopefully that knowledge that I've got in my head actually is enough to kind of make this work without needing to do a whole entire MPEG transport stream package. Although we probably will end up doing that because I think it's a pretty interesting container. Has a bunch of weird sort of ideas that maybe you don't see so often in the sort of modern IP world. Yeah, so let's get going basically. I'm actually super excited to do this. Hi everybody in the chat. So I'll just reply to these. I'll leave that over here. Will that work? What is the minimum latency that it could be? I'll just say hi, pew pew, hey, good evening, hi, good evening, good afternoon. What is the minimum latency that it could be? Yeah, this is hard. Sometimes the only way to find out is to actually just do it in the first place. With players in particular, how's it going? You have a mobile IP exam in an hour. Oh, wow. Okay, there you go. Hey, mate, good luck. Yeah. Hope it goes okay. I'm sure it'll be fine. The minimum latency. So the players themselves always do a whole bunch of buffering. I think MPV, that's an open source player that's available on a whole bunch of systems. That always does it, like by default, does 3 seconds. This bit here should be pretty quick. Of course, FFmpeg itself is doing a bunch of buffering and stuff like that. How did I know this architecture? So on Twitch, I actually just came up with it now. So I'm pretty sure it should work. But I came up with, I'm putting the screen. I came up with this bit. This stuff here is kind of how these, I guess this is just how these modern sort of streaming systems work. So there's actually a really cool article that I should link. Oh, sorry, Asad, I didn't see your message in the other. Wait, how many? It's the same. Sorry. Okay. Let me put that image down here so I can sort of see chat going at the same time. Yeah, cool. Let me put that there. Much nicer for me to have it here, so much easier. Okay. And I don't know about the YouTube chat API, actually. I do want to look into that. So there is a really good article from these people. It's about, it was essentially an article that was kind of compared doing everything yourself in terms of like a live streaming service versus outsourcing different parts of it. So I'm just going to say DIY. Nah, it was good. Yeah, this is cool. Okay. This is the article here. They have a good diagram. Yeah. These are what they call the functional components. I'd sort of call it as like the main sort of like processes. So you've got things here, for example. So in our case, we'd have video software would be OBS, and that's here is the RTMP bit. So in our case, we've got OBS, RTMP, and okay, we don't have, yeah, this sort of thing, whatever. And then we've got the normalization, bitrate, transcoding. So we're not doing any of that, but that essentially happens in here for us in Twitch itself. And then the manifest creation is the bit where you take the videos that you've got and you kind of make a playlist. So manifest is a playlist. We use the word manifest because depending on whether you're using HLS or MPEG dash or whatever else, it depends. And then you've got here what we'd sort of call like the normal serving HTTP files over the internet kind of architecture, where you've got a CDN like Cloudflare or Akamai or some data center somewhere. That's just, serving a whole bunch of like, to it are just a whole bunch of binary files. It doesn't know what they are. It's just serving them out as quickly as possible, doing as much caching as possible. So in our very bad, very simple architecture, what we're going to have is something that, we're going to have something that has, we could probably do, let's just call it the video software. We could also have the camera. And that's going to be doing something that looks more like a wired stream, because we're not going to use any network protocol per se. We're just going to be like doing it like raw over UDP or over the Unix socket using MPEG TS. So the media container is just going to be streamed directly over the network. Oh, well, not the network, but in our case, it's going to a Unix socket, but it's sort of the same. And then what we're going to do is we're not going to do any transcoding, we're not going to do anything. All we're going to do is do the manifest creation, and then we're just going to directly serve that from the same process. So it's all going to happen in here. I think it can be a pretty small, like surprisingly small, because yeah, Go just gives us a lot of stuff that we can just use straight off the bat. Yeah, how does that sound? Does that sort of make sense? I think we might be able to do it all today, actually. I know that sounds crazy, but if I really get going, I can probably hammer something out pretty quickly. It would be really fun if we could all test it together. So I'll just, I'll have a server somewhere that we can hit via the internet. And I might even just have a little reverse proxy that just connects to this computer right that I'm on now. I'm in Australia, so for most people in the world, it will probably be very, very slow. So we could think about, I could actually send it to Amsterdam. I've got a server running in the Netherlands where it's super fast. Yeah, that'd be fun. Should we, should we just get going? I've actually tested that this bit works over with OBS. So that just makes it a bit easier because I don't have to worry about making a very big complicated ffmpeg command. Right now I'm running a little ffmpeg command that does this, listens on loopback and writes out to 2 places at once. Hey, my wave. In Apple Watch. You can play video on Apple Watch? I didn't know that. Is that... with the... Yeah, wow. Yeah, okay, look, let's just get going. So we've got our little HLS proxy, which is not... Holy jeez, that's amazing. Seriously. Yeah, well, I mean, look, like it should be okay. I might, what I might do is actually just make the, let me just see, hold on. I've just got the OBS settings open here, just seeing bitrate. It should be okay. I mean, we're gonna be doing 3 megabit of video, so 3000 kilobits per second. It should be okay because we're not going to get that many people watching it at all, so it should be just fine. I'm worried about, these all these cloud services. I've got a little VM running on on just one of these providers, and that egress charge, when you get over a certain size, I mean, oh man, like just crazy pricing. Should be okay though. Yeah, let's get going. I think I'm actually excited. Wow, this is great. We're actually writing an application. We've been writing library code for like 2 weeks now. So it's going to be great to actually make a little application. Ingress for free. Yeah, that's cool. Yeah, hopefully, yeah, actually, I think, yeah, that's cool. Yeah, maybe, and look, I mean, if we were clever, we'd set up like a thing with a CDN and have it caching and all this stuff, but this is meant to be a really tiny thing. Now, I'm going to try and do this quickly just because I don't have so much time because family is getting home soon. But I think we can actually, it might be fun to do it kind of more quickly. And it's Friday, so, like, let's so first up, as I said, we're going to be listening on a Unix socket, and we're going to might keep this. I don't know if this is really readable, but this is, hey, go, mate. Yeah, this is, I don't know if you saw the, we just sort of ran through the architecture of this app that we're thinking of doing. But I think it should make sense as we go. So as I said, let's start our formatter. Yep. Here we go. Maybe I should, give me a sec. Maybe I can upload this to a web server, or maybe, sorry, 2 seconds. Let me just think how to do this. Yeah, we'll do it like this. This is going to be, let's close that. Let's put that here. Let's leave that entire column. Let's do this. And then I'm going to put my thing here. Is that okay? Oh, I'm not going to be able to see your answer. I'll just do this. Okay, as I said, let's, okay, we got that going. Let's, cool. Yeah, as I say, this should be fun. I'm gonna try and speedrun this thing. So as I said, we're gonna listen on a Unix socket. Let's go video.soc. No, AV. All right, this is audio as well. Audio is more important than video. I think we all know that, right? That's. And then I'll just do a. Okay. Why don't I go from FFmpeg to... okay. No, that is actually a great question. Yeah, so when I was sketching this out on Twitch, I did sort of the planning live on Twitch before going live on YouTube. Kind of came up with it kind of very badly. But the container that's actually used here is FLV, the Flash Live Video or something. It's actually from like the old sort of 2000s days. So basically, because the FFmpeg command that we've got running now to do this T writing here, where we read one and then go out to the others, and FFmpeg can do all of that in one go. But I thought it might be fun to kind of just be able to, in OBS, just click start recording, and then it just to receive, like kind of raw video directly. Just because it kind of exposes us to, and I think it might be interesting for people to see like how that MPEG TS works and the tricks that it can do, and how it's not, it's kind of a weird, well, no, not weird. It's maybe, I don't know. I think for a lot of people who do, of course, like me, like I've done so much web development, it's fun to see stuff that doesn't really work like that. Yeah, okay, so you know what, we actually just want to do one. Actually, I only want to do one except here, so we not said anything HLS. Yeah, I actually haven't done that much with HLS itself. I've always done sort of lower the stuff before HLS. Okay. So we've got our connections. That's our read writer. So let's so now we're going to start reading the data. Now this is the bit that is going to be the sort of the trick for MPEG transport stream. What we're going to want is we're going to do something like read media. Going to have a. This is actually just needs to be an IO reader. We don't even care about anything else. And then what we're going to want to do is read the stream and then start dumping it to disk, or at least dumping it to a file system somewhere. So we're going to want to chunk it up and all that sort of thing. So the first thing we want is, let's say we're going to have to estimate. Yeah, I'll go through it in one. So for the moment, let's just so I was thinking how to start this thing. Let's just do this. Let's just dump it. And then we're going to do dir string. Okay. And then we're only going to get an error. Okay. Now, here's a trick. My camcorder that I've got right here, when it does MPEG TS over UDP, it sends seven MPEG TS packets in one UDP packet. So an MPEG TS packet is, very quickly, basically a way of sending a little tiny bit of media in a fixed size 188 byte sort of structure. It has a bunch of information in it about timing, errors, what kind of information it contains. Does it contain video, media, a lot of clock stuff, because there's a lot of, and also information to synchronize things is really key in MPEG TS. That's what makes it good for streaming, is because you can just send the MPEG TS and then the receiver will have all the information it requires. Yeah, that is exactly right. Yeah, it is a good thing to know, because we know it's going to be, and this is also what makes MPEG TS kind of, it's still used in streaming today, which is weird because it sort of was done in the early 90s or something. But yeah, it's still used in like broadcast, TV, radio. It's still used in IP streaming. Action emerges from the shadows. What does that mean? Hey there. Yeah, it is. It's interesting. It's kind of, normally with computer stuff, if people are familiar with like the OSI layer model, you've got like layer 1, which is, or like the physical layer. Layer 2 is, that sort of, what do they call it? The link layer. So that's like a network switch. Layer 3 is the IP. You've got all these layers that each have their own concerns. With MPEG TS, it's kind of all, a lot of those things are smushed into one thing. So it makes you able to do things like just send data over UDP or even a Unix socket without any other information. And the players will still be able to go, oh yeah, okay, like I understand this, I get it, let's go. So what I'm thinking is we'll probably want to do something like we'll do a, let's call a, we can actually almost do a buff size, I can see, I don't know. I'll do 7 times 188. And 188 is the size of the, you know, MPEG. Do TS size equals 188. We'll probably use these around the place. Might not need that actually. Yeah. This is sort of like a 7 seems to be like a rule of thumb, especially because over the network, when you take into account like the MTU and how you know, packet like, what do you call that, frame fragmentation. Anyway, I'm going deep into network stuff, but I think that for the moment, let's just do oh no, so we go and into buff. Now we're going to handle this in a way. We're going to put this in a for loop, of course, but just leave that there for now. Actually, let's just return it just for now. This is going to be pretty dirty initially. We want to do, we're going to check, so what we want to do is absolutely make 100% sure that we've read a multiple of the TS size. Otherwise, you know, weird things start happening. Players can cope with that, but it will be better just to kind of drop the packet altogether. When I've worked with MPEG TS before, there's actually a bunch of ways to do the error handling here, but we don't have our MPEG TS library yet. That'll come later. Okay, so if n mod, oops. What are we gonna do? We're gonna reslice the, will we reslice the buffer? Is that what we're gonna do? Yeah, we'll do something like that. And obviously we don't want to keep making a new one, but anyway. Maybe we can actually just leave that out for now, because we are just doing this over a Unix socket, so we're not expecting a lot of things to go wrong there, right? Sorry, just... yeah, actually, fuck it. Let's just do this. Okay. Yeah, let's just do this. Now I'll need to, let's just do a little trial and error here. Actually, yeah, let's just do that. We're gonna have to do a bit of a hack here and just estimate the duration of the stuff that we get, because what ideally I want here is our program to chunk up the video that we get into something in between 2 to 10 seconds. I think for us, doing 10 seconds is probably gonna, well, Actually, it doesn't matter, but as long as we get something under 10 seconds, we're okay. The recommendation is to get the max, I think, is 11 seconds. This is from Apple, and I think in the spec as well they mention that. That's like the recommendation. Yeah, let's just, and also what we'll do is we'll use whole integer durations in our playlist because, yeah, as I said, this is a bit of a hack. Okay, so let's go n red plus equals n, and then do something like this. So for red less than or equal to, how many packets do we think? I mean, we're going to be, how many bytes do we think we're going to need? I think we can actually estimate it because we know that we're going to be doing a constant bit rate out. So we know that the bits, we've got 3,000. I mean, I know this just because that's what I've written in the, this is what's configured in OBS. This is another trick, by the way, with streaming protocols, is that they almost always use fixed bit rates rather than variable bit rates, just for this reason. So you don't have to like calculate anything when you do it. You're just optimizing for latency here, basically. So if you can know everything in advance, you can just do stuff like this and just dump stuff super quickly. So I know we've got 3,000, and I know we've got 192 of audio. So that's 3192. So if we do, so that's per second, right? So let's do, how many bits in a byte? 8, right? So we'll do 3192 divided by 8 is the number of bytes, and then we'll do, let's do 8 seconds because that's what we're yeah, so divided by n times 8, well, it's just going to be 3192, isn't it? Yeah. And then, yeah, and then we're, so that should give us 8 seconds. So you estimate. Now, of course, there's the overhead of the packet itself. Right, so in 188 bytes of stuff that we receive, you know, a whole bunch of that is going to be overhead from the actual float speed damned. Yeah, exactly. Yeah. Oh, IOU. Yeah. That's interesting. I actually haven't looked at all that yet, but. Yeah, for this kind of thing, it actually would be super interesting. Anyway, distracted. As I said, so we've got 188 bytes for in a single, per packet. But there's a whole bunch of stuff that is, hi there, good morning, good afternoon from Australia. Let's do something like, I can't remember approximately like the ratio of video data to the overhead from the packet, but let's do something like, why don't we just do 10? So let's just estimate it like that. I mean, say we got 3192, that's 8. And then we'll go 3192, all right, 3192 times, divided by 8, that's the number of bytes, and then let's times that by, let's do 10. Yeah, let's do that. Okay. Yeah, I'm just guessing here. What we're actually going to do is we're just going to run this program and see how much, like what the actual play duration that we actually get, and we'll just kind of estimate it from there. The worst that can happen for a player is that it's just going to be like really wonky. Like you'll see a whole bunch of weird artifacts and stuff like that, which is fine. Yeah, for now. The header of the actual play duration, or you mean like the header in the MPEG TS packet? Yeah, the thing is that right now we don't have it does, yeah, so normally it does have the duration in there, but at the moment we're not actually doing, we're not reading any of that information. So I'm just kind of guessing and going, okay, well, we're just going to split this up into some number of bytes and just write it to disk and just hope that it all matches up, because we don't have we haven't got a package yet to deal with MPEG TS packets themselves. We don't have a way to decode or encode it. Okay, so when we do that, now we're going to actually just let's do the segment. That's also going to be an integer. Let's start writing this. So we're going to do cache dir, right? So, oh no, we're going to get it from the dir. That's good. Okay. Maybe we could do yeah, anyway. Oh, this is going to, yeah, okay. Let's just do that. Okay, and then we got that. We could actually just do we could do write file, couldn't we? Let's do write file. I think is that the one? Because that handles all the closing for us as well. Name string data, yeah. No, that talk is when is that? That talk is next week. Yeah. I just wrote that up because they wanted like a summary and a title and that sort of thing so that they send it out with the announcement. Actually, I think that announcement is out. I don't know where. I don't know how to use this shit website. Okay, resident. Okay, here we go. There we go. It's on his phone. Yeah. Oops. Yeah, I forgot to give them a summary thing. Yeah, that's fine. There we go. Oh wow, Gary. Oh, Gary's doing one. That's cool. Okay. He's doing a PhD on programming language design at university, so very cool. So if anybody's around, here we go. I'll try and stream that. Yeah. Yeah, that would be. Yeah. Especially, I mean, for me as well, I think it would be really cool, and because I can actually understand it, right? Because it's in Go. You know, sometimes you see those ones and they're in like these like crazy functional languages, and I'm like, whoa, what? I'm way too dumb to understand this. Yeah, I'll try and set up the. I had to learn Haskell because of that. There you go. Yeah. Yeah. I'll ask them and see if because I've got a camera and microphone and stuff. I should be able to do a stream from there if anybody's interested. Okay. Let's go back to the coding. So we've got name perm error. Yeah, sweet. Okay, so if the buff, and then we're doing it's fine. Yep. Let's do a bit of error. Oh no, we'll actually have the segment number in there as well, so yeah, we can just do that. And then I think we're good. Let's check for our EOF here as well. So we'll do that in a sec. Write file, blah, blah, blah. Okay, and we'll just increment the segment that we're on. Start with 1, I think. Actually, no. And then we go back and then we read again. What I'm going to do is just, for now, put all this like that. Okay. Yeah, that's right. Yeah. So when you're doing it over UDP, they, at least this camera, sends 7 MPEG-TS packets in one UDP sort of datagram. And yeah, for real. Yeah, so yeah, it can be. Hey, let's oh, I know, we'll get EOF, whatever, it's fine. Let's just do that. Okay, so we're gonna go and then we're gonna put the con, and we're gonna send it to, let's do the dir and then the con, like that. It's just the, oh no, it's just a reader. Okay. Yep. Oh, yeah, okay. Let's just get it from the argument that we get in. So, args 2. I don't know what these things mean anyway. There's our chat here. I think it should catch that. Let's just see. Yeah, it should do, since we know that the length of the buffer is always going to be, yeah. But for now, we're just going to just see what happens. And then let's have a look. Media, blah, blah, and then I think we're done. So we'll go equals args 1. Yep. Usage. Oh, yep. And then we'll go. Okay, there's our. Cool. Okay, now I'm gonna go hop onto OBS here. I actually might let me just set it up so that we can all see. Morning TK99, how's it going? Yeah, let's do that. Is that gonna work? Yeah. So now, yeah, there we go. Settings, and then recording. There we go. So we're writing mpeg ts to that Unix socket. Okay, we ready? Here we go. Start recording. 3, 2, 1. Fuck. Yeah, just straight up as well. Oh. Thank you. Nice spotting. Yeah, let's do this. Yeah. Okay, so this is the bit where we have a handler at the end that removes the socket, but anyway, whatever. Do that. Okay, here we go. 3, 2, 1. Fuck. 0, not a directory. What? Huh? /0, what? How? Oh, the open. I thought this creates the file. Oh man, what am I doing? Yeah, absolutely. Yeah. Why am I even writing? Oh god. I needed to. Oh my god. Okay. Dude, this is what happens when you do it live, right? Like it's so. Yeah, these stupid things. Yeah, it is that. Yeah. Okay, so, doing it live it's weird. Like you just sort of. Okay, let's go again. So what we're doing is our command has got to be go run. We're going to write it to the temp directory. Yeah. So we're going to see a bunch of files numbered, and then we're going to go here. The directory already exists. Yeah. So. Oh shit, hold up. What's the... I'm just getting a warning in... Oh no, the bitrate just went down for a bit. Okay. Okay, wait a bitrate dip. Okay, ready. 3, 2, 1. No. Okay, that might be it. Let me just... at the end of it, let's... don't really want to do a log fader. Let's just do here. Okay, so defer... Okay, 3, 2, 1. Okay. Now if we have a look in this directory, okay, cool. Now what I'm going to do is, yeah, let's just play this out. Yeah, okay, so we need to do, what's the format? Contain. Just do FF player, I can't remember the thing for... Okay. Oh boy. What we'll do is let's cut all these files together. 0, 1, 2, 3. And we'll go, test.ts. Oh, yeah, there's a video. Oh, look, there we go. Hey, look. We got it. Okay, so what this is telling me is we need to read many, many more bytes. Sorry, let me just reply to a few chat messages here. Let's see. So, same note. Yes. Have I implemented many protocols from spec? You've got me curious. I was giving you a go XMPP maybe. Oh, yeah. Okay. I've also done DNS. DNS was really fun to do. Yeah, that was a while ago now. I think I did that a year, or maybe even, was it 2 years ago? I can't remember. Anyway, yeah, that was fun. So I made I made a very bad recursive DNS resolver. Any pearls of wisdom when approaching a spec? I guess so. I don't know. I think it's just, yeah, no, have a, I don't know. Go is really good for doing network protocol stuff. So I think that picking something that has a bunch of really useful primitives for doing that kind of work is super useful. With Go, for example, I'm reading from a Unix socket, but I could be reading from the, from anywhere. So it makes testing it really easy. And you've got this IO reader thing, which is great. So you're just piping stuff around, and the other thing that I would say is I had a look at, in Go in particular, I read the standard library. So on the one hand, of course that was very useful, because I'd run into weird bugs and I'd think, well, what? What's going on? And for example, in DNS, I didn't quite understand the difference when parsing the DNS messages over UDP versus TCP. There was something about the length of the header was different by 4 bytes. I think in UDP the size, and TCP you can But I would say if you can try and do something that has a bunch of maybe implementations already, so that you can kind of, if you really do get stuck, there could be weird edge cases that of course at first you're never going to cover, because why would you do something super complete? I mean, it just takes so long to get something really robust. I'd say that. That's super interesting though. When you do that, please share, post it online, live stream about it, whatever. That would be really cool. A bunch of stuff happening in Twitch here. Otherwise, it's really secure. Yeah, no worries. That would be really. I'd be super interested to see that. Yeah. Yeah, somebody. Yeah, that's. There we go. More encouragement from Twitch as well. Okay. Well, look. Are we done? Is this done? All right. Let's try again. Let's increase our size by a lot. Let's go. Let's do 3192. So TS size times. Let's do. Oh, what's a nice big number? 200. Whoa, big number. Ready? Okay, 3, 2, 1. Ooh, now that failed pretty quickly, but not as quickly as before. Interesting. Okay, there we go. Look, we got a bunch of files here. 28 did we get to? Yep. Okay, so let's maybe we want to. Anyway, sorry, I was just thinking there. Let's. Wait, why was I doing that there? Let's do it in here. Okay, so we'll add another window. Why am I creating new files? This is to. This is the bit where it's chunking up the media. This is just for testing. Yeah, that's actually a good idea. Yeah, that's a good idea. I'm really just kind of estimating here. I mean, as always, it's kind of that really rough approach is like, oh wait, we've already hit the limits of it. Should we make this smarter? It would actually be a good idea. You know what we could actually do is we could actually just set a timer, right? And say, hey, like after 1 second, send a message through the channel to this thing to stop. And then we can get a pretty precise thing of like, oh, well, we know exactly 1 second looks like this. We should probably do that, shouldn't we? That's actually that would actually be the thing to do anyway, right? Because we know it's going to be real time. So we could actually, actually set a timer and then, like what do you call that? Is it a ticker in Go? What's it called? Time ticker? Yeah, that's it. That would be very cool. So what we could do is we could say, hey, like every, let's say 4 seconds, dump the buffer to disk. 4 seconds, dump the buffer to disk. 4 seconds. Then we know the duration of the segment. That's pretty cool. Yeah, let's do that. Yeah, that's it. Yeah, exactly. Yeah. Yeah, let's do that. So let's create our ticker somewhere up. So down here. Does that give us the channel? That has the channel in it. Okay. So we're going to do this for every, let's do 8 seconds. And then we're going to give it it's going to be a receive only chan of, what does it give us again? A time? Yep. Okay, now we're going to need a select statement somewhere around here. I think select is what we want. So let's do it up here. We've done this, select. If we get the, I can't, oh geez, I haven't written a select statement in ages. I wrote like I wrote this like huge application once that used a bunch of stuff from, because I can't remember it now. I'd not say a huge application, but it was a good one. Yeah, flash the internet. That's it. Yeah. So we're going to do the select, and then if it's time, then we're going to dump to disk. So we're going to do, hopefully this is fast enough. We could optimize this, but who cares? Yeah, and then all this. Okay, so bang here. Is default the one we want? Yeah. Let's get rid of that. Don't need that anymore. Don't need that. We're gonna need a bigger buffer. We're gonna need an actual, let's call it a, rather than this, let's use something like that. And then we can just do io.copy. That's the thing to do. Does that give us... yeah, it does give you that then. Okay, so io.copy from to buff from the reader. Now, I think you can, what I want to do is bytes. Because I still want to read in chunks of, say, you know, something like that. Because I still want to make sure that I'm reading in the right amount of yeah, let's say new buffer buff. Yeah, maybe I can just do like that. So we do I think we can just do something like that. All right. So we're going to copy in from the reader every time. We're going to, oh, do we want to, maybe we should do a read full. Maybe we should do that instead. Yeah, maybe we should do a read. Exactly len buff bytes from R into buff. Yeah, maybe that's what we want. Or will this behave the way we want it to? We want to get that many packets. Oh no, because the buffer's only that big, so no, we're going to do read full here. So we're going to actually indeed have a like that, and then we're going to have another one that's going to be like, so these are like our segments, so, and then our buff is actually going to be that. So from the reader, we do, whoops, what is it? Buff. That's easy, okay. And then does it, there is if only if no bytes are read, if you ever happens after that, return n equals len buffer, right? I can't remember whether I need to zero out the or like empty it after that, but anyway. And now that's good because that handles it for us. Returns the number of bytes copied and an error if fewer bytes were read. Bang. EOF happens after reading some but not all the bytes. Readers unexpected EOF. Okay, great. And then we just do something like we'll copy that into our big buffer, I guess. Something handy for this? I can't. Oh, I can write. What is it? we're going to write the file from segments dot there, so the contents of all that. And then we're going to do, after we've done that, we need to clear the segments. So that's segments dot, what is that, truncate or zero or something? Reset. For use by future writes. Yeah, great. Okay. Awesome. Then we just do reset. And away we go. Now that is better. Oh, sorry, I didn't see this. Can I just append all segments into the one file? Yes, we can. I was just kind of thinking, yeah, I actually should have done that initially. I think I got ahead of myself, and I was just thinking, oh yeah, we'll do the chunking up and all of the copying in one go. But I should have just done it in one hit first and then done the chunking afterwards. Yeah, that's a good idea. What's going on here? Yeah, the only thing is that it's going to be doing it right now. Oh no, it'll only start when, yeah, great. It'll only start when we get the connection. It's awesome. Okay, we ready? Okay. 3, 2, 1, 1, 1, 1. Oops. Well, that didn't work. This should just keep going forever. Well, might need another way to signal it to stop, or we can just kill the whole thing. Doesn't matter. Yeah, I think that's it. Yeah. Yeah, and then can't you send it? You can send that with the ticker, can't you? Like the ticker has a, yeah, stop, yeah, and then that sends the... Doesn't close the channel though. Yeah, that's actually what we want to do, is just close the channel. Yeah. Okay. Yeah, so we could just set up a, yeah. Is that a bit better now? Yeah. Column here. Sorry, chat, you're being relegated to the right-hand side. That can go. This here. Yeah. Oh, okay. Yeah. Send the. Yeah. But will the... Oh, yeah, of course. I still need to... Yeah. I still need to... I can't just close the channel because I've... Yeah, we need to send a signal, don't we? Yeah. Yeah, that's it. Okay. Yeah. So we read that. We write to the directory that we're given. Time. So we keep appending to the buffer, right? So we, no, it's still going right to the buffer, right, and then, oh, we got something. We got a ticker. Okay. Time to, flush, like basically flush, right? That's all we're doing. We're just flushing it to disk, to the file system. And then we keep going. Well, yeah, and now reset, keep going. And we got a new name there as well. So, doesn't feel like 8 seconds to me. I don't know about you, but oh, it's, yeah. Oh, do I need to start the ticker? No. That is, yep, that is exactly right, yeah. So we're gonna keep, normally I have a piece of paper here, but I don't have iPad and blah, blah, blah. But yeah, that's right. We're gonna keep reading in the, we're just gonna keep reading until, yeah, we'll just keep reading and then segments and just reset them. Yep, that's it, yep. This is actually a much better design. Yeah, this is, yeah, same. This is weird. I've kind of stumped myself here. So read for, yeah, we're just gonna keep going. Yeah, we're gonna read from it. Yeah. Read. This is just a reader, right? So we're not getting anything weird there. Yeah, I know. I had a quick look at the chat API this morning, actually. And yeah, it looks possible. Certainly for reading, it should be fine. I think it just looks like we're just going to have to do like a poll every, like 3 seconds or something. Maybe probably do it every second. It's just YouTube. Fuck them. They got loads of pipes and, well, they got loads of cores that can handle lots of connections, right? And we'll just keep one HTTP connection over. Yeah, see, it seems that way. Yeah, just from a quick, I had another quick look this morning, but yeah. And I guess for me, because I'm just speaking to the chat, so I guess I don't necessarily need to write all the time. Okay. Yeah, right. So it sucks. You run out of quota pretty quickly, but it might be enough for me. Yeah, fingers crossed. Yeah, because it would be a lot easier to just like, yeah, because we could just dump the same, you just write it to the same window in Acme. So you just, you don't need to worry about like, anything. Yeah, I'm are we getting an error though? Are we getting a I'm getting AOF. Okay, 3, 2, 1. Fuck. Fuck. So weird. It's like, how? What are we doing? Select. Oh, is it? Have I got my select? Hold on. This. It's been too long since I've done that. Okay. That was actually probably the project that I was most proud of, which was dealing with this super flaky, really fucked HTTP service that was just sending TCP resets. So I built this Go package that would handle all the reconnecting, all this sort of stuff, and sending a whole bunch of information through a channel so that you didn't know that how fucked up that thing was. You would just read from the channel and receive the stuff very happily. And then, yeah, that was, and then that itself then would start up like thousands and thousands of timers at a time. And then that would actually tell it would actually it spoke to a bare metal encoding device, or like big racks of encoders. And it would say, hey, you got to record this thing now. Hey, you got to record this thing now. So the program would read in this like super fucked up stream, like with just HTTP API, contained a bunch of data. And then, yeah, the thing would kind of just swap all the time based on a bunch of schedule information that we were reading in. So it would just, and then it would handle cancellations and all this sort of stuff. So it was pretty, yeah, it was, I mean, Go for that, like, oh my God, like that was just like, I don't know, like in a sense, like almost like the perfect Go application, like the perfect application of Go's features. So it was, yeah, but yeah, it was reading all these, anyway, yeah, let's, I'm just saying this out loud because I'm trying to remember to myself how it did stuff so that I, because of course there were a bunch of like really important like select statements in there, and I'm like, wow, how exactly did they behave again? Select. I know. Okay, so this default is wrong. So it because it'll only do this once. we want to keep doing this. So I think this needs to be in a for loop. Yeah, that's it. Yeah. So it's actually this, but because this is non-blocking, we're okay. So let's just grab all of this and then, yeah. So we should have another case in here that, you know, is going to handle the thing from, you know, from a channel that signals, hey, we're all done. But we don't have that at the moment because we suck at programming. Okay, I think, is this going to be right? Yeah. Okay, here we go. 3, 2, 1. Ooh. Can you see? Oh no, you can't see the recording. There we go. See? Oh, look at that. Very professional. Big red button. It would have been fun to write in C. Yeah, and I know, like, God, the number of lines of code, that stuff that I would never be able to do myself, you know, like all this non-blocking stuff, like, yeah. That would be really cool, actually. Oh, okay, hold on, let's let's kill the recording. Sweet. Wow, that is... Yeah, true that. Yeah, that's true. Yeah, but I'm a noob, man. I can't writing, you know, doing KQ and BSD and ePol Linux. Like, I need Go to do all that for me. I'm not smart enough to do it like raw dog. Okay, are we ready to watch this video? Oh shit. Oh no, you can't see the recording. There we go. See? Oh, look at that. Very professional, big red button. Fucking hell. That fucking worked. Oh my God. Oh, you didn't hear the sound. Hold up. Okay, we're going to do another one. Ooh. Can you see? Oh no, you can't see the recording. There we go. See? Oh, look at that. Very professional, big red button. That's awesome. Yeah. This is the thing. I actually, okay. So the last night, no, sorry, the night before last, I went out and got super drunk, and I actually finally met in person the guy who introduced me to MPEG TS, and yeah. I think it's one of those things where it's kind of one of the more analog things in the computer world, where I think text is sort of feels quite analog as well. You know, you can kind of read it without doing anything, and you can just kind of like stop reading it and like start again, and it doesn't, and you can seek around it. It doesn't care. I think it's the same with MPEG TS, right? Like you don't, like we're not even handling like stopping it very well, right? We're just saying, oh, just stop. Don't know when, like just as long as you've read some bytes, it's fine. But the player just works, you know, no problem. For example, just to really make the point, right? Let's say, right, we wrote out these 4 files, yeah? Let's just cat them together, yeah? And then we'll read them into FFmpeg, right? We're just reading from standard input. Ooh. Can you see? Oh no, you can't see the recording. There we go. See? Oh, look at that. Very professional, big red button. There we go. See? It would have been fun to write in C. Yeah, and I know, like, God, the number of lines of code, that stuff that I would never be able to do myself, you know, like all this non-blocking stuff, like, yeah. That would be really cool, actually. Ugh. It's so cringe watching yourself do these things. You know, when you hear your voice, oh. Everybody hates their own voice and stuff, so that's okay. That's normal. Oh man. Images too. Yeah. So somebody on YouTube commented, and they were curious about whether we would. Yeah. Yeah. Somebody on YouTube commented asking if I would look into SMPTE 2110. It's called. So that's SMPTE 2110. And one of the things that what that's used for is like real live, on-premises production environments, like big TV studios and movie studios, stuff like that. It's a way of, instead of using the thing that we're familiar with, like raw video signals, like for example, a HDMI cable, or they have these other ones called SDI is used in broadcast, not HDMI. But anyway, it's a way of replacing that with just normal IP. So it's kind of a suite of standards. And one of the things that it does is, you mentioned images, it actually uses this special JPEG format to send video around. So as long as you've got like a super fat pipe, then this is like this super low latency way of, and very like high quality way of sending AV data around. So that might be something that we look at later as well. I didn't know about it until this person commented asking about it, but when I looked at it, I thought, wow, that would be pretty cool. Because right now we're relying on the H.264 codec and the audio AAC. Yeah, but it would kind of be fun because then you can like literally just like open the stream and just just look at a picture and go, oh, okay, I see what that is. Whereas for H.264, of course, there's a lot of complexity there because, you have a bunch of, like magic stuff to squish everything down into a really small size and blah, blah, blah. But again, like we'll see, because I don't know whether it'll be that interesting because it's hard to demo, right? Like we don't have all that gear. I mean, of course, we all have switches and Ethernet cables and stuff, but so that would actually be cool. I mean, it would certainly like kind of exercise the networking gear. And the cool thing about it as well is that like the software to do it can actually be pretty simple because at least you don't need a lot of like resources to do it. We know with things like H2, like, if you HEVC or H.265, or we have the VP9 codec, and now the AV1 codec, like they're really amazing. They can really squish things down, but they require a shitload of computing resources to even just to play back. The cool thing about this other side of the sort of video world is that, just decoding a JPEG and a special case JPEG where it can be done in like a tiny amount of memory. I mean, that's also pretty cool, right? You just need the good hardware. There was, I'm just going to finish this tangent by linking one of these articles that I've found very enjoyable. It's from Dan Liu, which I'm sure some people know. This is about how, essentially how like all this JavaScript stuff is impacting people with slow devices. And in particular, it covers how recently bandwidth has actually become quite cheap. It mentions it here. So before, of course, I think that, and especially older people will know, I even remember too, right? Like especially in Australia, there was like no bandwidth. But the hardware was like, for me, like it was okay. Like I do pretty much the same thing on the computer as I did when I was 10 years old on Linux. No, I installed Linux when I was 12, yeah. So let's say when I was 12 years old, so that was the, whenever that was, early, 90s, 2000s. No bandwidth. But the CPU performance was fine, That's changed now where actually we've got like way more bandwidth now, but the hardware hasn't gotten, of course it's gotten faster, but it hasn't really been optimized for all this web stuff. And this, I think the same goes for video stuff. I think that we'll see more of this going forward, especially as latency becomes a concern, like as latency is becoming more important for the way people are using computers and, not computers, but for this sort of, especially video stuff. Anyway, let's, communications. All right, so I'm just going to link that because I thought that was an awesome article and that will end my tangent. Sorry. Here. Okay, so in that tangent, I was just kind of happy that this thing worked. I just wanted to take a break and just sort of enjoy the bit where it's working before everything starts breaking again. I'm going to turn the light on as well. 2 seconds. Yeah, it's yeah, and it's fun, right? Like people love doing it. I'm like, people find it really interesting if that makes sense. I don't think, people think, oh wow, Raspberry Pi, that's really cool. Of course, Raspberry Pis now are like super overpowered for what they're originally meant to do. But anyway, well, this is great. So now we know that these segments that we're writing out are approximately eight seconds of playback. One thing we can do is we can run ffprobe on it. And I think it should tell us. Yeah, duration 7.97. Okay. .807. Okay, that's pretty good. It's still a little bit out though. I mean, I would like to try and. That's 7. What's that? 7 milli. Yeah, right. Okay, it doesn't. Okay. That's probably okay. Let's just let's see where we get up to there. Okay, so we've got 8 seconds. Is that it? Yeah, that's good. Okay, we don't really need that now. We're using this value just because, this is... we don't know where we're reading from here. We could be reading from the network. We could be, whatever. So we'll just use that. Okay. So now what we want is to actually, let's create a playlist for this stuff. So how we're going to make a playlist is we're going to read the directory, maybe find all the files that are MPEG, have like .ts files, and then that's it. So oh, more people here. Be a little bit like using I read full segments.write. If you want to, oh, here we go. Wild hardware. What's the utility in that? Hey there. Hi. Sorry, I didn't see. Why old hardware? What's the utility in that? Try to formally verify the correctness of use something set a memory or set a time that generates every issue user one idea. Maybe io.copy would a little bit more than using io read full segments.write. Yeah. Can we do that? The only thing is that we want to, how would I limit the, what I want to do is actually make sure that I'm only ever reading in chunks of this size. So I only ever want to read that much at a time. Because I think with io.copy, it just reads all the way until it hits like EOF basically, right? Yeah. Copy N. Yeah, that's the one. Yeah, I remember. That's what I did in my DNS package. Nice. Okay. Awesome. That's nice. Beautiful. Thank you. Thank you. So we're going to go, let's do that here. I'm going to, maybe I'll just make a, yeah, okay, let's do this. Read from, so we're going to write to segments, and we're going to from reader, and then we're going to do that many, oops. 7 times TS size. Yeah, exactly. I mean, we're putting a lot of pressure on the we're relieving a lot of pressure now. Sweet. Okay, so let's go there. Does that give us a number of bytes? Yep. It's going to do that for now. Beautiful. Oops. Okay. Yeah, we'll just do that and then we'll go. Oh, I do too. Forgot about that. Yeah. So the buff size is not really the name I want. We want to set that as something like maybe max. Max something. Because this value is the kind of like the safe number of bytes that you can fit into the, for MPEG TS in a single datagram. On typical networks with, so that you don't fragment the, so that you don't fragment the packet, the datagram. But let's do that. Okay. As I said, let's do some playlist making. So let's go. Yep, and then we're going to go from the directory. Whether we need to and then anyway, let's just do that, and then we're going to return a playlist and an error. Okay, so the file path.glob, is that the one? Yeah, okay. That's W run comes right. Yeah. W runs with Win API. So, yeah, I've never done any C programming on Windows to see wide string constant about HPAC. Yeah, that's right. That's a G, isn't it? Yeah. Yeah, is that the sync? Is that the sync byte or something like that? Yeah, I've got auto dark mode. Oh, 2 seconds. Let me just grab this call. How do I do this? Okay. Hi. Is that all back on? Yeah, it looks good. Okay. So let's do this file path.join and then so each of these is going to be if we open up our doc playlist. So this is a structure that we're going to want to fill out. Let's go. We'll just start with a literal and then go from there. So we're going to m3 do 8.playlist. The version is going to be 7. That should actually be a constant, but we'll do that later. The segments, is that the one that we want? Let's fill out these other things first. So we want the target duration is going to be 8 seconds. The end, no. The type is going to be, I think it's playlist type. Okay, playlist none. Wait. Playlist event. That means live in HLS terms. We're filling out the no start point. No, we don't need that. Just continuity sequence. I think that's it. Okay, cool. Let's read our segment. So go doc segment. So I can't remember what this looks like. Okay. We're not doing byte range, not having discontinuity. There's no encryption. We're not doing map. Date time, no. Date range, we also don't need. So it's really just going to be the duration and the URI. Let's try that. So we're going to have the, oh, sorry. Yeah, no, that's it. Okay, cool. So let's do that. Okay, so for, so name in names, so, whatever. Let's just say, URI is just going to be the, in our case, it's just going to be the name of the file. We're just reading it straight from, like, we're going to use the Go's built-in HTTP file server to serve the file. So just having the name is totally fine. And then we've just got the duration is also, yeah, we're just going to do just, I'll just do this, yeah. Okay, so playlist.segments, and we append it to the playlist. I think that's it. Oh yeah, M3U8. Time dot second. M3U8 dot. Now, why isn't Go imports getting me my playlist event? Yeah, segment. Okay, whatever. Now I can't remember how the players actually read the playlist. So like whether they just request it again or whether they do like a long poll get or or what, I don't know, I can't remember. But I think we should find out pretty quickly. So we've got our playlist making thing. Why don't we just, oh yeah, we've got 23 minutes left to finish this thing. So do it nice and quick because I've got to make dinner for somebody. So let's, are we gonna make a little HTTP server now? Let's just for now, let's just start a little Go routine. I don't care about a Go routine to say times on after, is it? Then sends a current time after func. And then calls F. Yeah, great. Okay. And we're going to let's just dump it to standard error for the moment, just to see what it looks like. The playlist. Okay. So getting that running, what we're going to do is we're going to do after, what is it? I think it just does it T. But I don't think we need the timer, do we? No, we don't need the timer because we're just going to do it like this. So after, let's say like 8 times, how many seconds? Let's just do it after 4 seconds. Let's make a playlist. Our arguments are just the dirt. Okay, easy. We throw away the arrow, who cares? Might be interesting. Maybe we do want to keep the arrow, I don't know. Yeah, let's do that. This is a bit better. Oh no, we can just return. Okay, and then we print that out. Okay, and then we close that off. And we close that one. Okay. Now, the question is, are we feeling confident to run this? Here we go. Okay. So we're going to do 8, 16, no, how many seconds? 8, 16, 32 seconds. Ah, that's too long. Let's do 16 seconds. We've got 2, let's do 3. Oh, I need to get a, need to listen for the, yeah, the SIGINT. All right, okay, let's go. 3, 2, 1. Recording. Say hi, everybody. You're being recorded. How fun. Oh. Yeah, tick. Okay, great. So that's one done. We'll put everybody here too. There we go. Oh, there's our playlist. Oh shit, hold up. What? Test.ts? Oh fuck. Yeah. My bad. Yeah, shit. Okay, hold up. No. That should, okay, great. Let's try again. So now what I was doing is that I'm not naming the files correctly. So I need to, the dir is going to be media, the name of the file here, plus.ts, yeah, there we go. That's a bit, yeah, obviously we need to do the file names and tidy all this up, but damn it. Okay, shit, I always called the stream. Okay, are you sure it's exit? Do I want to exit? No. Okay, 3, 2, 1, beep. All right, we've got one segment, I think. No, we've got zero.ts. Wait, why did it only do... Okay, we need to tidy up here first. And leave those 0, 1. Actually, no, we can get rid of them too. listening. Yep. Try again. Oh wait, no, I'm gonna kill it. What we want to do is, let's get that little bit of a race condition going on there. Okay. Now in a little bit we should see a there we go. One. Cool. All right. That looks okay to me. So now, let's make a little HTTP server that actually, that serves this thing. Yeah, let's go. So serve HLS. What do we need? A http.response. Oh, let's do it. String. Is that right? Yep. And then we're going to return a handler func. Let's do this first. If we serve the playlist from the given directory, then we're gonna give back a I think it's a serve file. No, okay, let's just do that. Okay, so the server is a given directory. So how do we make that? So our playlist is just going to be make playlist from the given directory. If that happens, well, then we're really fucked. So we need to return that. Okay, let's just go like this. Okay, return func. Oh wait, no, that is, yeah, it's like that, isn't it? Yeah. Okay. And then we're gonna go the encoded, so it's just the m308.encode the playlist. Okay, this is, and then we're gonna go w dot. What is that again? Okay. So w dot, we're going to set the header to be the thing that should probably be a constant, which is, I can't even remember now. What's this bouncing at me? Oh, yeah, okay. So that there is going to be, well, anyway, it's the content type I'm talking about. And then this is, I should make this a constant right now, really. Type. There we go. Care about the bytes right now. Oh no, this is a. Just do that. Does our encode thing actually write it to the writer? I can't remember. I hope it does that. Yeah, damn right it does. Okay, there we go. And that's it. Now we're just going to do this. Now that doesn't need to exist because we're really just going to be serving from the path that we give it on the we give it here. So let's do this should be in its own Go routine. That'll be, yeah, are we happy just to have that in a Go routine? Is that what we want? Or do we want to maybe start the server and then, nah, let's do it like that. Let's do, I can't remember this now. Does it on the default marks? Yeah, great. So the handle pattern string. Okay, so pattern is going to be, so that's the playlist.m3u8. Okay, that's the magic one. And then how to handle that is we give it a serve playlist, again, just from dir. And then okay. Hi there. Hey, 6412. Or boarded good morning, as we say here. Oh, wow. Where they key 6 what? What language is this? Oh, this is Welsh, isn't it? Ah. MIME type, it's not an acronym. Oh, it's not an acronym. There you go. Nice. I know, I thought it did feel a bit weird to me. Yeah, I remember before talking about whales. It's cool. Yeah. How are you going? I'm well, thanks. I now I've got to finish in about 5 minutes, so it's getting really close here. If this actually works. Now it goes like, oh man, this the file server thing always gets me. Like, we need a, HTTP dir os dir fs blah blah blah. What is HTTP fs? Yeah, that's it. Okay, HTTP. So fs. I'm cooking today. Cooking dinner. Or cooking dinner. So we're just going to handle everything else as the HTTP OS. Of dir. Is that it? File system, and then HTTP file system. What does that give us? Interface. What is it? HTTP. File server, HTTP file server. Oh yeah, you said that you were going to give it a go. Yep. Yeah, it's sort of like it's definitely like a kind of little environment, yeah. And especially the way you can like manage processes and stuff, it's super weird, yeah. Oh, oops. Yeah, we can just dump all that. Oh, header.set. Yeah, header.set that. Oh, function that returns the thing, and then, okay. We can get rid of this now, I think. Started IRC and SSH. Oh, the IRC worked in there? That's surprising because it doesn't, like it can't, yeah, because it doesn't do, it doesn't do like like it's not a terminal emulator, if that makes sense. Yeah. Oh, yeah. It's weird. That is one thing. Like it's all text, but there's no terminal there. It's, like it doesn't implement any escape codes or like color or anything. Yeah. It's very much like more like an interactive piece of paper than it is a a terminal. Yeah, that is really cool. Yeah. Yeah, that's that's true. Yeah. Well, maybe what you need to do is undo some of the magic, eh? Okay. Here's a big moment. Okay, we're 2 minutes over. Okay, come on. Let's see. Is this actually are we just gonna, is it first try Fridays? First try Fridays? What do we think? Playlist.m3u8. Fuck. No, we don't want that. We want this thing. Oh no, it's I put the wrong port. Oh. Was it a... Is it doing IP? Let's do that. Am I just not even listening or something? What's the go here? Oh man, so close. So close. Am I just like... Is it because I'm in a rush? I can't get this server running. Is that it? The handle? Yeah, handle. You're gonna... Yeah. I'll do the TCP at least. Whoa, okay, we've got TCP, blah, blah, blah. Is it just not binding? What's going on there? Am I losing it? We get the connection, we pass on to this, it takes it, and then we... Oh, because we haven't... Okay, hold up. Okay. No, fuck. Okay, hold up, because we haven't started like writing to the socket yet, so it hasn't kicked off the whole entire thing. Okay, ready? 3, 2, 1. Okay, we're recording. Great. Okay, we're writing, and then if I... What are we doing here? It's just going to do that. So, okay, there, we've got one segment. Let's... Page not found. Bzz. Oh, does it need to be the other way around? I always forget this, like the... how it handles the specificity. 8,000, right? Playlist.m3u8. Oh baby, oh baby. Okay, here we go. Let's play this thing. Let's play this and then we're good. Come on, you fucker, come on. Come on. Oh no, it's got the zeros wrong. Oh no, it's so close. Okay, hold on. So the directory is, oh, it's so close. Okay, here we go. Temp, we're gonna do, on the URI that it writes out, we're just going to do a quick hack. Make playlist, the URI names. Here we go. The name is actually not name, it's just path.base of name, right? Oh, come on, we're so close. Yep, good. Come on. Oh no, we're gonna start recording. Come on. All right, there. Have we written a segment yet? Come on. Oh man, this is killing me. Okay, okay, here we go. Ready? Let's go. Motherfucker. Oh fuck. Oh no, it's so
Yes!
close. Hold on.
Yes.
So the directory is.
Yes.
Oh, it's so close. Okay.
Oh my god. Okay.
We're gonna do.
We got
the
it.
URI that it writes out. We're just gonna do a quick
So now
hack.
it's streaming itself. Oh my
Make
god, that's
playlist,
amazing.
URI names.
So look, live broadcast. So it's actually just. Oh man.
Actually not name. It's just part.
Oh. This is actually good because we'll see like what does it need to be. You know, if we need to do a long poll on the playlist or what, let's see. It just returns it in one go. So if I, oh no, there it goes. Oh, it's fetched it again. So that looks like it just played one segment and then that was it. But every time we make a request, what does that do? Serve playlist, and it actually makes a playlist again. Oh no! It's here we go. 8.ts, 9.ts. Oh yeah! Look Oh yeah! I'm changing. That's a different picture. Okay, I really need to go. Oh, sorry, I didn't miss. We're going to cook here in a minute, which means that I'm going to break food to the gas station. Oh, man. I think this. I don't know whether it's really gonna. Oh wait, are we still? Oh yeah, no, OBS is still recording. Let's have a look what we've got in our. Let's fetch the playlist again and just see what we got. Oh, look, we need a sort. Yeah, that's it. Okay, so it's probably freaking out there. Because what'll happen here is that the timestamps in the packets like are going to be all fucked up. So the decoder
like the video decoder is going to be like, well, what the hell do I do? Like I'm jumping all over the place. So it's probably just like totally crashed. I know this because I've fucked with the MPEG TS packets and like adjusted timestamps, and I've watched all sorts of players fail in really weird ways. So I'm hoping it's that, which would make a lot of sense to me and is a really easy fix because... Okay, but look, on this note, I'm actually going to have to go because I'm going to get in trouble. So, hey, that was super fun. This is actually like the first application, like actual real application that we made with all these sort of packages that we've wrote, libraries, all this sort of thing. And I think, yeah, not quite first try Fridays, but, you know, maybe like third try Friday, something like that. So yeah, as always, I don't know what the fuck's happening there, but anyway. Yeah, this was super fun. So if, as I say, subscribe to the mailing list. No, actually, no, don't subscribe. Like, what the fuck am I talking about? Don't subscribe. Just if you ever feel like you want to send anything there, if you want to like, yeah, you don't need to make an account. It's just email. So if you want to like share any sort of feedback, if you think something would be cool to look into, really anything. I'm a super easygoing guy, and I'm super curious to hear also like what other people are working on. Yeah, so thanks again. Thanks everybody who has donated. This is like absolutely incredible. Now that we finally have a server, we're gonna use this donation money to actually, like serve this stream, have it self-hosting, and we're gonna, pay for the hosting costs with these, I think we've got enough to, like we don't need a lot. So it's great stuff. All right, I'm gonna stop recording to myself. Very good. Our HLS server has finished okay. And now I'm going to stop streaming. So I'm going to kill my RTMP connection. So just as a reminder, I'm just going to put this picture back up again. We actually did this, which is great. So we replaced Twitch in... what do we reckon here? How many lines of code? 114 lines of code. That's all Twitch is in the end, hey? Alrighty. We're going to go here. Okay, so thanks again, everybody. I got to go cook dinner. Have a good weekend. Have a good morning, afternoon, evening, wherever you are. Okay, thanks again. Thanks so much. This is learning so much here. Cheers. Bye.